Hey, hi again. This instructional video is about solving quadratic equation using the AC factor method. Students were coming up to me asking, can you give us some more examples on that? So here it is. So first recall that a standard form of a quadratic equation is written as ax squared plus bx plus c is equal to 0. Okay? So in this case, the leading coefficient 6 is not a 1. So we have to use the AC factor. And to do that, we list all the multiples, the factors that gives you a 6. So in this case, we got 1 times 6, or 2 times 3. Now look at the C term. This one's easy. It's just 1 times 2. So now we're going to use our gut instinct. Yeah, the word we used was gut instinct. And we said, what kind of gives you a feeling it will work? Well, in this case, I said probably 2 and 3. Because 1 and 6 is too far apart, that the numbers will be either too big or too small to get a negative 7 later on. Here's how it works. And here, there's no choice. You have you have 1 times 2 only. So let's do this. Let's say, if I said 3 times 2, the product of that is going to give me 6. And if I said, then what remains is 2 times the 1. And that'll give me 2. Well, can the 2 and the 6 added or subtracted give me a negative 7? For example, 6 minus 2. Well, that's a 4. And 2 minus 6. It's going to be a negative 4. But it's not a negative 7. So that's not going to work. So let's try the other way now. If I took those two multiples, and this time if I said, how about 3 times 1? Well, that's going to be 3. And how about 2 times 2? Well, that's going to be 4. Well, can 3 and 4 somehow become a negative 7? Yeah, but this time it has to be negative 3 and negative 4. Because negative 3 plus negative 4 gives you negative 7. So now we're ready to put them in a factor form of the equation. So the leading coefficients 2 and 3, they're always positive. So it's going to be 2x and 3x. Now the question is, what numbers do we put in there? Well, for 3 times 1 to be a negative 3, this one has to be negative. And for 2 times 2 to be negative 4, the 2 has to be negative. And so 2 times negative 2, for them to multiply, if you put a negative 2 here, they don't multiply. That's not the way the FOIL method works. That means you have to put the minus 2 on this side of the parentheses. What remains, you put a negative 1 here. So now, you're going to use a zero product property. Set each of those binomials equal to 0, so you can find the x. You're going to solve for x. Here you go plus 1 to both sides of the equation. You got 2x is equal to 1. Divide the 2 to both sides. One of the solutions to this equation, which will make it 0, is if you put x equals 1/2. So that's a solution. Or the other solution is when you solve for this x by adding 2 to both sides and divide the 3. The other possible solution is when x is equal to 2/3. If you put that in, substitute it into this x and this x, they will equal 0. There's your two solutions. Now let's have you try this one. Okay, so now you said, I kind of got the idea now. Again, the leading coefficient on this one is 10. It's not a 1. So you have to use the AC factor method. And you start to list all the multiples, all the product for 10. You said 1 and 10. You said 2 and 5. And, oh, that's it. Yeah, that's about it. Now, that's a dead giveaway right here. There's no other choice. It's either 1 and 21 or 3 and 7. Now, what does your gut feeling say? Did you say 2 and 5? That's what I would say. And did you say 3 and 7? Yeah, that's what I would say. So now, which one do you multiply? So let's just go right ahead. How about if we said 5 and 3? Well, 5 times 3 is 15. That leaves you with 2 times 7. And that's 14. Holy moly, we got lucky this time, because 15 and 14 will give you 29 if you add them. But how does it become 29? Well, they both have to be negatives. And for this to be negative, 5 times negative 3 gives you negative 15, and 2 times negative 7 gives you negative 14. We're ready to put them in factor form of the equation. Here we go. So once again, the leading coefficients 2 and 5, they're always positives. So we got 2x and 5x. Now, how do we decide which of these c terms we put in there? Well, we want the 5 to multiply with negative 3. And if we put a negative 3 together with the 5, they don't multiply like that. When you do the FOIL method, you have to put the negative 3 over here. And that's would have been the FOIL, the I part, the inside. That means negative 7 is over here then, because that'll be the part of the FOIL outside. The multiples for 10, we have a choice of 2 and 5. And multiples of 27, that's 3 and 7. And the way I checked to see if they're proper, I said, let the 5 multiply with 3. That'll be 15. And the 2 then multiply with the 7, that'll be 14. What must their signs be? They both have to be negative. Sounds good. In order for the 15 to be negative, 5 times negative 3, that had to be negative. And also, 2 times 7 has to be negative to get a negative 14. Okay? However, when I put them in factor form, these are always positive, 2x and 5x. The 2 has to multiply with the 7, so 7 went over here. And 5 multiplies with the 3, it has to come over here. Now the FOIL method, on the FOIL method, the last one of the terms, when I did the multiplication, it was negative 3 times negative 7. Problem is this, negative negative becomes positive 21. That is not the C term we needed. So this was not, no, correct factor form. So, but I didn't give up on the multiple choices here. So I said, instead, why don't I make it 2 times the 3? 2 times 3 would give me 6. That leaves me with 5 times 7, which will give me 35. Now what can I do with those two? That will give me the middle term 29. Well, here it is. 35 had to be negative. 6 had to be positive. And they would also, the sum of those two numbers will give me negative 29, which works. And those two numbers, 5 times 7 has to be negative to get 35 negative. 3 has to be positive. Those C terms, when I multiply them, it will give me negative 21. Now that's what I needed over here, negative 21. So that was my error. So now I could put them in a factor form, 2x and 5x. They're always positive. 2 has to go with 3. The FOIL method says it doesn't go this way. It has to go that way, so 3 goes over here. And then negative 7 comes over there. So if I solve this completely, by using the zero product property, we got 2x minus 7 is equal to 0, or 5x plus 3 is equal to 0. Solve for x by adding 7 to the first equation, we got 2x is equal to 7. Then when you divide the 2, one of the answers has to be 7 over 2. Solve for the second one by subtracting the 3 to both sides. So we got 5x equal to negative 3. Divide the coefficient 5. My second solution is x is equal to negative 3 over 5. Now I hope this works. I hope this works. Thank you so much for that contribution as submitted by one of our viewers.